Okay, so there are two. One is, as I said, what do you call that? One is evolutionary. The other one is throw away. So throw away for what? After collecting all the requirements, of course, can be a few rounds. First round, second round, third round. After collect all the requirements you want, you don't use the prototype anymore. You start your development, a new system fresh. So that's why it is throw away. Meaning you don't really go and throw, but you don't use it, scrap it. Okay? So meaning this throw away prototype just to collect requirement. After that we don't need it. So we just keep aside. So that's why throw away. Okay? The other one, evolutionary. After collecting the requirement, you come back, you fix it. You try to modify. Okay? Then go and get the second round feedback. Modify. At the end, evolutionarily, it will become the actual system. So evolution. Evolutionary. So meaning your prototype slowly convert into the actual system. That is evolution. Okay? Evolution. Slowly. Okay? So there are two types of prototyping to collect requirement. Same thing goes to validation and verification. You have two types of other prototyping to validate the requirement. Again, the same type of people. They don't even know how to give you the requirement. Do you think they know how to validate requirement? Verify requirement? No, they don't know. So you have to go for again prototyping to this kind of client, this group of client to validate requirement. So there are two different types to validate requirement. We will look at that. You know what? This topic is quite popular for final exam. The prototyping for validation and verification. Okay? Okay. Next, don't get confused between elicitation prototyping and validation prototyping. We are using different approach. Okay? Acceptance test, last one. Before that, model validation. After you draw a lot of diagrams, right? How do you validate your diagrams? How can you guarantee that you have drawn a very good diagram, perfect diagram? That's what we're going to cover in model validation. And finally, acceptance test. Okay? So it's a very short chapter. Okay? Okay, so finally we are in the last phase. But you know, right? After this, there's something else you need to learn. All these four phases can be repeated. Okay? Because customer or client can come back to you with changes. When they come back with changes, this will be repeated. So that is requirement change management. One more chapter. Okay? Chapter 7. Now chapter 6. Okay? So we're going to proceed with validation and verification. Another word, okay, for requirement validation and verification is quality assurance. Requirement quality assurance. You know, right? What software engineering, when you develop a software, there are so many phases. Every like design, development, coding, then you have testing. Every phase you will have quality assurance. So requirement quality assurance is the last part of requirement engineering. Okay? Okay. So now, first thing, who can explain clearly to me what is validation, what is verification? I remember I asked, I guess in the lecture 1 or lecture 2, beginning of the semester. So I told you we will discuss this towards the end. Here is the chapter. Okay, who can tell me the difference? Okay, according to this validation, okay, you have adequate requirement document, items, real needs. Okay, this one, completeness, consistency, and blah blah blah. So what is validation? What is verification? It is quite clear, but I'm very sure not everyone can understand what is explained here. So who can clearly show me the difference between validation and verification? They are not the same. Okay, ATM. You go to the ATM, you insert a card. First, verification or validation? First is verification or validation? Validation first. What is validation? What is verification? Verification is first check whether the item itself is proper, a proper one, a real one. So for example, the card that you are using, instead of putting ATM card, you go and put your touch and go card to withdraw money. Can or not? But nowadays machines are very smart. They don't even let you insert the card. If it is not, okay, a valid card. Okay, so first stage, check the card itself is a proper card or not. If it's a correct card or not. So you don't need another source to compare. You don't need another source to compare whether this is correct or not. This is not, just use that card itself, you check whether the card is proper or not. It has whatever bank card supposed to have. So that is actually verification. Check for the correctness, completeness, as you can see there. Okay, that is we call not correctness, sorry, completeness, okay, consistency, and all the other quality. Okay, we check within the card whether the card is the real card or not. That is known as what do you call that? That is known as verification. After you insert successfully, you type the password. That is validation or verification now. Validation or verification. Insert the card, type the password. So your ATM will check whether the password is valid. That's validation, because validation means you have a source, the real information, the correct information, then your version. Compare both, check whether they are same or not. That is actually validation. Okay, always you have the actual one, the real one, and you have your version, check. Compare, that is validation. So always compare the version that you have with the source. That is validation. So now requirement also same. First, before you can go to the client, because client are the people who come up with the requirement. They are the source. Before you go to the client, you yourself need to verify. Your team need to verify. What is verify? Check whether you have written all the modules. Have you covered all the modules? Have you covered all the users? Have you covered all the requirements? Okay, have you used the correct notation? Have you missed out any information? Do you have repeated requirement? You have clashing requirement? All these are verification. You don't need source. With the knowledge, you can check yourself. So that is verification. After that, you go and check the requirement with the source. Who gives you the requirement? Is this what you want? Correct or not? That is validation. So validation always need a source. The source and yours equal means valid. You understand or not? So how, like just now ATM, you already registered for a valid password. So that is the source. Every time you insert the card, your password must be the registered password, must be the same as registered password. Validation. So verification, validation are two different process. Okay? Validation, you need to compare with the source. Okay? Verification, you check the notation. If you have drawn the use case diagram using the correct notation, ellipse shape, got boundary line or not, got the actor and use case connected or not, got the connection or not. All these are verification. The requirement correct or not? Validation. Understand or not? Okay? You need to understand this to differentiate model validation and model verification data. Okay? Okay, so I hope you understand. If you don't understand, ask, I will give you different example. Okay, so now, okay, you can see various product resulting this phase. At the end of this validation and verification, what do you get? Consolidated requirement document. I mentioned this in the first lecture itself. Acceptance test data. Okay, can anyone tell me how you get the acceptance test data? You know what? Your test case, right? For test case, you prepare the test cases based on your requirement document. That's why they don't wait for development, you know. You have an independent testing team. We don't select our development team as testing team because it can be biased. Okay, because always when I see my code, I don't see my mistake. So when I see my work, always is good for me. So we don't ask the same team member to become the tester. We have an independent team to be the tester. So usually you go work one day, you can see a big company usually will practice this. They will have a testing team. The moment you finish your requirement document, right, one copy will be sent to the testing team. And testing team will start preparing the test data and test cases. They will start preparing the test case. Okay? Once, you don't even start your design and development, but testing team will start your test cases and because independent. So later after you complete everything, right, it's not based on your coding, The test case, like you all do for FYP or assignment, you all prepare your test case based on your code. No, they prepare based on requirement document because it has to fulfill the requirement. So they prepare the test case, test plan based on the requirement document. After you complete your coding, they will use the test case to see whether your code achieved what expected by the client. That's how the real world. If multinational companies, they seriously have a testing team or testing department to do this. Okay, you can even now if like big company, multinational companies, you can just work as a tester. You don't have to do any development. Okay, there are a lot of positions in the multinational companies usually. Okay, development plan. Yeah. So once you're done with the requirement document, right? Now you can plan your development. You can come up with a schedule. You can see how many modules are there, how many people needed. Okay, how long does it take for each module? Everything can be planned. So that's why your schedule or your development plan will be prepared by the project manager. Okay, and finally sign the contract. You can bring this document to see your client to confirm the project. So of course, you need to compete with some other companies. If your quotation is good enough, you can get the project. Okay, so these are the things. You see, very important. Once you're done with your requirement document, the validation verification, your project now can be started. Basically, your project can be started. You sign the contract, you prepare the development plan, or you prepare the acceptance test data prototype. You can also, get your consolidated final document of requirement. Okay, so that's important. Okay, so now we're going to start with the review and inspection, the first type of validation and verification. Okay, so there are two types of inspection. First we look at the various forms. Okay, one is walkthrough, internal inspection by the project members. Okay, you just ask the project members to go through. Walkthrough means like go through the document. You're done with the SRS, right? So just go through. Then more structured, more proper one is called review. Okay, so external review, well prepared meetings, inspection report. Obviously this one you will invite the client or you go to the client place. You will prepare a few copies, pass to different types of client, like select a few of them, pass individually. Usually you go for individual review. Pass to them. I will go through this in detail. Okay. Then fairly common source code and all this can. Other techniques. Okay, the other techniques. Empirical studies also can. Okay, go through like research, study, find the mistake. Okay. Okay, these are the steps in inspection. Okay. Okay, as you can see, first you plan for the inspection, then you invite, the people, when you plan, you will determine what's the scope of this testing, this validation, verification. You have to select who are the people going to involve in this inspection. After identifying, of course you can have one or two team members, but mostly client side, different people from the client department. After identifying all of them, you need to pass a copy of the SRS, no RD, SRS. RD can, but not consolidated RD. SRS, okay? You pass a copy to everyone, individually review. You know why individually review? Why we don't ask, normally review, right? We don't ask everyone to go and sit at one place and review together. Why? Even your exam paper, right? We have 5 levels moderation. Why we don't ask everyone to sit together and moderate? Why? First, after I set the paper, moderator will moderate, then reviewer will moderate, then our AD, then our TD, and finally external review from other local university most of the time. Like UM. My lecturer came last time to review my paper. Okay, so these are the things. So why we don't ask everyone to sit together and review one shot? Save time. Why we don't do that? One of the university I worked, they do like this. They ask everyone to sit together and review. And the meeting can go, actually they plan for, like say 1 hour for review, right? It can go up to 3-4 hours also sometimes. Why? When you ask, there are few things, few drawback when you ask group review. When you ask a group of people to review, one thing, arguments, unnecessary talking and all that will take place. Number 2, someone in the group can influence the others. When you find the mistake, the others can simply say, no, this is not a mistake, acceptable. So that can influence the other member. So you cannot really find the fault. So not good. Group review is not good. So here you see, you go for individual review. Pass a copy to everyone, ask them to go for review. Then when they come back, you have a meeting. See, defect evaluation meeting. So not everything that every member have found, consider as error. You just ask them to review first, their opinion. Then when they come back, you will go through question number 1, go to exam ready. Okay, let's say requirement number 1 or module number 1. Okay, what's your finding? We listen and then we discuss and agree, don't agree. We go part by part. So now more effective. Don't influence each other. So you already found your mistake, but so you just voice out. Everyone else will check whether it is fine or not. The others will help you to validate and verify. Okay, so that's how you come to a conclusion. And finally, here go your RD document, RD consolidated document. Clear? You prepare the document. So after your review, you have all the correction. Go back and reproduce the document, rewrite the document, become RD consolidation or consolidated document. That process, rewrite the document with the correction, consolidation. Okay? Clear? Okay, I think I've covered. Yeah, here you can for the review, right? Individual review. How do they review? Everyone has their own idea how to review. How can you standardize? This is what I want you to check. Because there are more than 1,000 things can be checked. You can check the grammar, you can check the notation, or you want me to check the diagram, you want me to check the content, what to check. So you can actually go for free mode, just let them check whatever they want, find whatever mistake they manage to find, or you can go for checklist based. This is quite good and this is quite common practice. You prepare a checklist, what to check. Then everyone will get a checklist also. They will go one by one item in the checklist to check. Okay, so that is another thing. Then last one is process based. So everyone will get a role. Okay, you are a language specialist. You check the language. You are the content specialist. You check the requirement. You're going to be the format specialist. Check the format. So we have role. Also can. Okay, these are the common practice. Okay, so checklist quite popular. So I have something to show you regarding the checklist. But before that, yeah, inspection report should be your inspection report at the end after done the inspection, right? It must be informative, accurate and constructive. Okay, inspectors should be independent from RD authors. I write the document, I prepare the requirement and I be the inspector. Can or not? That's why when you develop the code, you cannot be the tester. You should ask another development or another project, okay, team members to become your tester and you can be tester for other projects. You understand or not? We don't select the same team members to be the tester. It's not valid. Okay, then where did I stop? Okay, representative of all stakeholders. Yeah, try to find different category of people. Not only manager. You should have someone from the low level like staff, clerk, receptionist, anyone. Okay, inspection should come not too soon, not too late. Yeah, this inspection shouldn't be very early or very late. Okay, then more. If it's good, it is good if you can repeat. You have enough time to repeat, it is good. Okay, more focus required on critical parts. Yeah, important features, important modules, spend more time. Like login, simple modules can maybe go through quickly. Whichever important, higher priority requirements, pay more attention. Okay? Okay. So now checklist. I told you, right, checklist is common practice. So you can prepare a checklist, ask them, okay, what I want you to check. Okay, so we have a few types of checklists. Defect driven. Okay, defect driven basically find all the defect. Okay, so all the defect. Okay, so you see list of generic questions structured by defect type. So you ask questions such which can double check whether there is any defect or not. So all the questions will identify the defect. So you just when the question is given, the reviewer will read the question and look for that defect. Got or not? No means no. So check whole document ready, done. Okay, so that is defect driven. I show you example. Quality, we check on the quality of the document, how the document is written. Okay, so of course defect-driven questions can be used here, but more on non-functional requirement. Okay, based on guide words, often focus on omission. Okay, some like hidden requirements and all that. Okay, domain specific checklist. This one knowledge to test whether the system really applicable for the domain. Okay, that you have chosen for this project. For example, medical system, right? We don't know anything about medical, so we try to check if we have done all the medical part related requirement correctly or not. So we try to have a checklist. What are the things we need to check, like formula, for example. Okay, if the formula correctly used, for example, okay, medical, for example, all the terms have been identified correctly, so all the domain related one. So later you will have a specialist or expert from domain side will help you to check on this. Language based checklist. This one to check on the language. Okay, so let's look at the example. Okay, defect driven. Okay, defect driven. What are the defect we will check? Is there any omission? What is omission? What is omission? Hidden assumption. So one requirement, like something is hidden within the statement, not really explained clearly. Okay, hidden. So that is omission. See whether every requirement, go through every requirement to ensure no omission. Contradiction, conflict. Okay. Then inadequacy. Okay, not appropriate. Okay. Ambiguities, ambiguous. One statement can bring like more than one meaning. Okay, like lack of clarity. Okay, unmeasurability. Yeah, this is always there in your assignment. Okay, so your assignment, we are the validator, we are the people who are going to review your assignment. Because you do until SRS, right? Then you submit to us. So we're going to check your SRS, we're going to validate and verify your requirement document. So usually, right, when I check my students' work, I see this. Okay, non-functional requirement, you say, like last week, okay, the downtime must be as low as possible. What is as low as possible? Measurable or not? Can I confirm that this system is reliable? No way, because as low as possible, how to know what is the low value? Okay, so that is unmeasurable. Okay, then noises, unnecessary information, actually irrelevant. No need to put in the document. You go and write all that. Also, always in assignment. When I ask you to prepare the requirement document, I don't know. You go and start like essay. There are two types of elicitation technique, observation. Passive observation, active observation. The meaning of passive observation is all this needed or not? Requirement document. This needed or not? You are not writing, you are not preparing lecture notes. You are preparing requirement document. I always see students go and write unnecessary information such as definition. Okay, list down all the techniques, list down no need. You have to just explain how you implement. We don't want all the general information. You understand or not? So that is noise, considered as noises. Yeah, sometimes over specification. You don't have to mention until the form code what are the field. You cannot be over specified. Later design team decided not to have certain field. It will be clashing with the requirement document ready. They have their own reason for designing. So you cannot touch their part. Go and mention what are the field in the form must be there. Oh, that is over specification. You just say prepare a registration form. Okay, load a registration form to register. Enough. That's your part. Later they are going to decide what are the fields going to be there. What are the fields will be validated. All that design thing will do. It's not our job. Okay, so over specification is not needed. Okay, that can trouble the whole project. Unfeasibility. Oh yeah, my final year project student always can come up with a proposal. They can come up with idea which is so super duper. Sounds very interesting. But feasible or not? What is feasible? Sometimes when you propose very AI based project, okay, like IoT based project, you see whether you can find the devices or not. Like for example, attendance system, okay, implant at the entrance. So when someone enter, okay, you can detect the face and automatically mark the attendance. Okay, sounds very interesting. You can, as a student, can you find the sensor? Can you operate the sensor? Can you integrate the sensor with your camera to detect or to capture the image and send the image to the system? Can you integrate all those three? So feasible or not? Can you find the device in Malaysia or not? If you buy the device from China or Korea or wherever, can you try to understand their instructions or guidelines to integrate with your system or not? Okay, or you can receive the product on time or not? Lot of things. So feasible or not? Beyond this, budget. Can you afford or not as a student? Within your budget or not? Can you get any sponsorship or not? All this are feasible. You understand or not? FYP, I think proposal you all need to write this. Right? Feasibility. Technical feasibility, operational feasibility, economical feasibility. So that's the thing. Feasible or not? Can do it or not? Don't come and tell towards the submission, Miss, I cannot find the device. Miss, I cannot do this. That's wrong because you didn't do research. Okay? So that's the unfeasibility. Unintelligibility. Intelligent enough or not your system. Okay? And remorse, deep regret, guilt. Okay? So has this concept been used already before this definition? So you have to make sure something, when you introduce, right, a word or whatever, make sure that exists. You don't come up with a new term or whatever which never used before. So no one able to understand later. So that kind of words, we call it as remorse, that kind of concept. Never introduced before, but you are trying to introduce a new one. But if it's in practice, no problem. If no reference, you shouldn't have such thing. Okay? Okay, poor structurally. Okay, you all know what is that, so I don't have to tell you. Okay, so like structuring means one use case you use font 20, one use case you use the font 8. All mix up together in one document. Cannot. Okay, opacity. Okay, not clear. I cannot see. Blur. Okay, the information is not clear enough. Poor modifiability. You put your requirement in such way where I cannot modify. Okay, all the requirement must be written in a way where it is easily modified or modifiable. Okay. Okay, so that's all about this defect driven. Okay, next, quality. Okay, see any unspecified response. Any unspecified response out of range input values. Array. For example, you say here this create an array. Then your array is out of bound. Okay, you say check with the last element, but you put, let's say array size 100 and you put element, last element is 100. That is out of bound. So let's say you mention here got can up to 1000 menu, can be up to 1000 menu, but somewhere you mention 5000 menu. That's example of, okay, out of range. Unspecified response to receiving expected input, too early or too late. Okay, meaning you haven't even get the response, but you already started using it somewhere. Okay, that is wrong. Okay, any recovery operation in case input saturation. Okay, see whether any recovery operation used or not. Any output producible, all these are quality, checking on quality. Faster than it can be consumed, same concept as this. Any input from sensor unused by the software controller. You say there's a sensor used and then the information from the sensor will be used. But in your requirement, the sensor is there, but the input from the sensor never used anywhere. So what's the point of having the sensor? So that kind of unused information. Does every state sequence from hazardous state lead low risk state? What do you call that? Any sequence of information can cause some unwanted things in your document. So that can be counted as like noises. Okay, is there data consistently checked? Yeah, as I said, the notation. Okay, so your notation, right, you have to follow certain notation. One diagram you use for ERD crossword notation, then another part you use different notation. You can also say multiplicity, one you use 1 to star, then the other place you use 1 to n. Star and n both also infinity, but you are using different notation and different diagram. So shouldn't use, you have to make sure consistency throughout the document. Okay, one place you use different word, another place for the same term you are using different word. Okay, shouldn't do all that. Okay, last domain specialist check, we can skip because domain can be any domain. So like medical, as I said, you have to check all the medical term correctly used or not, medical calculation all correctly done or not. So we need someone from the domain expert, domain side expert to come and check for us. Okay. So now, lastly, language. Okay. So you have to make sure statement identifier used consistently. Okay. Correctly referred. Does the indicator type of statement correctly refer to the requirement, assumption, and domain? Measurable. Okay. Rational, consistent with the stated objective. Priority, consistent. Okay. All these are under language. Okay, so language example, syntax checking, type checking, semantics, static semantics, circularity checking. No variable is being defined in terms of itself. Okay, so you have to check all this in the document. When you introduce a variable, see whether the variable is used. Okay, it's not used, unnecessary, need to remove during this stage, validation and verification. Okay, a diagram, okay, which you find not really explaining anything, unneeded, remove. Okay, so those things are, let's say two diagrams are not consistent, you need to fix it. Okay, this kind of validation and verification will be done during this stage. Okay. Okay, so I think you can go through yourself all these examples. These are considered examples. Okay. Okay. You can always, for language specific checklist, right, you can always include decision table or decision tree, because it can help you to check whether you have done correctly or not. Okay, see the what conditions and the response. So if the condition different combination, you get the correct response or not. So that is actually one example, one way to check on your language. Okay. Okay, now come to the strength and limitation. Okay, review strength and reviews limitation. Strength, experience to be even more effective than code inspection. Later, rather than checking the code, it's good for you to check now itself the requirement. You inspect the requirement, you can save a lot of money from testing later. Because when you check the code, you don't really see the mistake. But later, when it comes to testing, people will start finding out after testing the system using black box usually. Okay, so that will be more costly to fix. So it's more effective to conduct review during the requirement engineering. Okay, wide applicability. Yeah, so any defect type can be found at this stage. Easy to find. Okay, burden and cost. Yeah, many people say requirement engineering is waste of cost because it's costly. When you don't have enough time, you're going to waste money and time on requirement engineering, especially validation and verification. No guarantee of not missing any important mistake. Yeah, sometimes you cannot give the guarantee that you're going to find all the mistakes. You still can have some mistakes left out. Okay, so these are the drawback, these are the advantages. Okay. Okay, prototyping. Okay, so today validation and verification, I'm going to introduce two more types of prototyping. Important. Okay, so let's look at them. Okay, so we can use prototyping technique to validate requirement. Okay, validation tool. Okay, it's a type of validation tool. And like your customers are not even able to give you the requirement. How can they help you to validate the requirement? Okay, so if they are very good IT background, okay, they have enough experience, they can help you to review. But if unable to review, how are you going to make them validate the requirement? Prototyping is the choice. Okay, so now let's look at, okay, this one you want to go through. Meets users' needs. What are the things you can check through the validation? Okay, using prototype. Meet users' needs or not? Complete or not? Feasible or not? Possible to develop or not? Because when you develop prototype, it's already a proof that you can really develop the real system, correct or not? When prototype can be implemented, okay, then the real system of course can be implemented. So proof, okay? Then complete, yes. When they try, experience the system, they can see whether the function works completely or not. So it is checking for completeness, okay? Meet user needs, yeah, you can check whether it's like they want or not. So if not like they want, they can feedback. Okay, clearly communicate. Yeah, easy to communicate. Easily communicable. Okay. Okay, two types of prototyping. Class mock-up prototype, proof of concept. Okay, this is not proof of concept. Proof of concept prototyping, mock-up prototyping. Okay, let's tell you what is mock-up. What is proof? If you know the words out. What is mock? When I go for, let's say I apply for a job. Okay, when I apply for a job, usually as a lecturer, they will ask me to do mock lecture. Okay, unless someone recommend you, they already know you are very good, they don't ask. Like recently, I'm getting a part-time call. Then, you know, the dean itself calling me to come and teach. I don't have to do mock-up. But let's say when I apply one university all by myself, I have to do mock-up, okay, or mock lecture to show that I have a good teaching skill. Okay, mock. So that's the meaning of mock. You know why they call it as mock lecture? You know who will be sitting in front? No students. All the people who are going to assess me, evaluate me, will be my students for the day. So like when I went for it, when I joined APU, I was quite young, just newly married. Okay, so I remember, what do you call that, the HOD, senior lecturers, HR, those people were sitting, asked me to conduct lecture. And the lecture, they asked questions non-stop for 30 minutes. They call it as mock lecture. Why? Because pretend like the lecture, pretend like a student. So when they ask question, I have to treat them like my student. I have to pretend myself teaching in front of a student. So same here, mock up. So what's mock up prototyping? What's mock up prototyping? Anyone? So we go one by one. Okay, mock up also called as horizontal. Horizontal prototyping. You know what is horizontal and vertical, right? It's easier for you to understand if you remember this word. Horizontal, vertical. There is a reason for me to show like this because it's easier for you to understand as I say. So this is what do you call that? Horizontal. This is vertical, right? So remember, mock-up is horizontal. Why? I have a reason now to show that. Focus on a portion of user interface. You know the 7 layers when you develop a system, right? A system made up of so many layers. What is the frontmost layer? Front or outermost layer that interact with the user. What is the outermost layer? Easy to remember if you listen to this. What is outermost layer? You all didn't take any data communication. OSI protocol content or not? Basic foundation one. Content or not? So what is the outmost layer? Interface. Then we have other layers, correct or not? After interface, what's the next layer? Usually we have the control layer. Whatever data you collect from the interface, you do the validation at the control layer, correct or not? So the processing layer. Then you have your data layer, then you have your network layer, blah blah blah, one by one layer, right? So this is the system layers. You don't really develop system like a cake, but a system is made up of so many layers, technically. We don't see, but technically. Okay, so these layers are very important to understand this. So your outmost layer is interface, right? So you only test the interface. You only test the interface to understand if the system works as you wish. So that's why mock-up prototype is known as horizontal prototype. Only test the horizontal first layer. Okay, so focus on a portion of user interface, doesn't dive into the deep features, deep functions, and how it works, operations. Now, even the database, how it sends data, how it receives data, or no, we don't bother. We see the interface working as we wish, okay, fine, pass. So we only test at the surface level, which is known as UI level. Okay, so that is mock-up. That's why the name is horizontal. Horizontal because of that. Okay, so you remember this horizontal, you can recall, surface level. Okay, so only use the UI to do the validation. Okay, understand or not? It displays the facades of user interface. Screen permits some navigation. The normal prototype with very little features, all the interfaces, and usually with the navigation. No features, maybe little features. So just test the interface. Okay. So it lets to explore some specific behavior. When I try to register, how the system responds. After register, what happened to me? I can log in. So you understand the navigation. You can understand how the system can be explored. Understand? So this is used for users, okay, or your client to validate. Okay? So those who have no experience explaining requirement, they have no way to validate your requirement. Okay? So they will use prototype, especially horizontal prototype, mock-up prototype, to validate. Understand? This one, quite popular question in exam. Comparison between mock-up and what do you call that? The other one is what? What is the other one? Yeah, proof of concept. Okay? Okay, so done with that. So this is an example. So you have the interface, you have all the button, click, navigation. So click, go to the next page. So can show how the system can be explored, can show how the system navigates, and what will be the response. Okay? When you perform an action. Okay, what is proof of concept? Okay? Now, I told you right, interface layer, then control layer, then data layer, blah blah blah. So many layers, right? Okay, now this is to check whether the system is possible for you to implement or not. Can people come out and tell, okay, I want some project on this, but then sounds very interesting. And the vendor, when you ask vendor to develop this system, vendor say, yeah, we can do it, no problem. And you're going to invest so much of money. Imagine after 6 months they come, they say, we used up your money, but the project is a failure. Who going to be? Who going to lose? Who going to lose? All your money burned. As a client, your money gone. So you can ask them to, please come up with the proof of concept. I want to validate first. See whether this is what I want. So they don't develop the whole system, you know. You have so many layers, right? They only take one component. Just take one component, maybe just detect the sensor part. Okay, detect the sensor and pass the data to the system. Only one component. And then for one component, you do all the layers, complete all the layers, but you don't do the whole system. You only do one complete component. That one feature or one module, you do completely all the layers until you receive data, send data, everything. So that one module or one feature, a group of features maybe, you do until the end, all the layers. So when you do that one component until the end, it is a proof that this can be done. Correct or not? It can be implemented, the project can be done. Proof. Okay? So this prototype is actually to show that the project is feasible. So when your client asks you to come up with a prototype, okay, you develop one component completely. Not only the interface, everything, completely. Okay? Until the network, send data, receive data, everything, completely. Then you show them, demo to them. Okay? If it works, proof. It is working fine. So you can proceed with the whole system now. Understand or not? So that's why horizontal and vertical. Vertical means completely implement all the layers for one component, not the whole system. Understand? If you remember these two keywords, right? Horizontal, vertical, you can guess how to explain. No need to memorize. You understand what I mean? Okay, hopefully. Okay, so I proceed. So I have explained all this. You can go through yourself. Okay. So just to quickly go through one thing. Use when you are uncertain whether a proposed architectural approach is feasible and sound, or when you want to optimize the soundness of club solution, test critical timing requirements. So you want to know whether this is possible for the team to implement or not. So FYP also sometimes your supervisor can ask you, when you propose something, can you do this one small functions using this new algorithm? If it works, we will proceed with the project. So proof, to prove that you can do it. It can be done. Okay? Okay, so anything? So I think all have been mentioned. Members, include members of multiple user classes, both experienced and inexperienced. Meaning, when you want to do the validation with prototyping, right, you invite people who have experience using IT systems, people who got no experience like new user, first time user. You should have all kind of people. You shouldn't be only focusing on people who have experience. You should also include first time user, people who have never seen IT systems before, never experienced at all. Also must be there. Okay? Okay, prototyping evaluation. Okay, how to evaluate? Does the prototype implement the functionalities in the way you want? Okay, you expect. What functionality is missing? Yeah, when you see the interface, you can come up with some modules or some functions are missing. Very easily you can detect. Can you think of any possible error condition prototype doesn't address any unnecessary functions present? Yeah, you didn't request, but then it's there. Okay. How logical and complete does the navigation works? Sometimes to do a small function, you have to navigate like 20 times. Can you simplify this? All this can be spotted during prototyping. Okay. Are there ways to simplify any task that require too many interaction steps? Were you ever unsure of what to do next? Stuck. Usability not good enough. Not guiding you what to do next. All this can be evaluated, validated. Okay, so prototyping risk. Pressure to release the prototype. Sometimes when you do a prototype, maybe you are just using auto-generate tool. Okay, auto-generator. So this prototype is not the real coding. You are just use the generator tool to generate. Sometimes clients don't understand. They ask you to release this because they want the system as fast as possible. So they ask you to release the prototype as the real system. As a developer, as a technical people, we know it's not possible. But to make the client understand, oh my God, it's very difficult. Okay? Then distraction by details. Yeah, when they are too into the interface or whatever, okay, they expect something like that for the real system. But real system, we will be focusing on the interface or features, functions, features, quality, right? Okay, then unrealistic performance expectation. Yeah, imagination. Okay, then investing excessive effort in prototype. Sometimes people find prototyping is waste of time. You can spend the time to do the real system, to develop the actual system. You are wasting a lot of time on the prototype, then you have no enough time to develop the real system. So some people feel so. So all these are the risk. Okay, now validation, model validation. Okay, for model validation, right, all these 4 types of models have been taught in this course. How can you validate them? Okay, now comes your verification and validation. See whether you can understand or not. I give you 2 minutes. Can you understand or not? What is verification, model validation? Try to read these 2 lines and see 2 statements. Okay, what is verification? Okay, let's read together. Check whether you have drawn the requirement model right. Drawn the model right. Is the model correctly drawn? Okay, your requirement models have the desirable properties described in chapter 3 to 5. If use case, right, when I was walking the other day when you were doing the midterm test, right, I feel like fainting. You know why? Some of you were drawing rectangle shape for the use case. Every use case I saw rectangle shape. Some of you, in your drawing, I saw the actor was floating there. Why floating? You didn't even connect to any use case. I thought, oh, maybe the student will come back and connect later. Then I purposely walked again to check. But still, when almost near the submission time, still the actor was floating there. No linking. Oh my goodness. Notation. Okay, notation. You have to know the notations correctly. Every use case must be linked to the either actor or another use case. You shouldn't have any use case floating or any actor floating there without any link. You shouldn't have. You understand or not? Then, use case diagram. Do you need an outline? Do you need an outline? What do you call the outline? What do you call outline? Boundary line. Boundary. outside of the system, what is covered in the system, what is not covered in the system. So I noticed this one many of you needed to draw the line, outline. Final exam also every semester I will have so many students forget to draw the outline. I already told you use case diagram going to be there for every semester. Okay, so don't you what do you call that, need to remember that outline, boundary line is the first thing you need to draw. Okay, draw as quick as possible so that you can cover all the functions. Okay, remember. So these are the notation you need to check. Correct or not? Correct or not? Do you need to check with any book or any source? Class, do you need your client to check for you this on this? Do you need your client to check on this? You technical person, requirement specialist, you should know how to write requirement models correctly, how to draw models correctly. Correct or not? So this is something called, okay, notations, format. This is verification. Verification means you know how the model need to be done. So you check whether the model is done in the way it's supposed to be. So that is verification. See whether the model follow the notation, follow the rules, follow the standard. That is verification. You check based on the rules and regulations. So that is verification. When you have a source, you know when you have a source, the real one and your version, same or not? Same or not? The source and your version must be the same or not? That is validation. So now tell me, who are the requirement source? Who are the source of requirement? The sources, who are the sources of requirement? Your client. Okay, they are the ones request you to develop the system, right? So they know what they want, correct or not? Now, the model's requirement, okay, have been drawn correctly as the source required, the source expected. That is validation. So checking on the rules, checking on the format is verification. Checking on the content, the requirement is actually validation. Okay, so always validation means you see whether your model is drawn correctly as expected by the client or not. So that how can be done? Check whether the requirements all correctly drawn or not, correctly identified or not. Your model show the requirement correctly or not. That is validation. Verification, you don't need client. We can check ourselves. We check whether the model follow the correct format, correct notation, correct standard. That is verification. Understand? So verification, validation, two different words. Now, can you relate with ATM? What is verification? What is validation? So like the card, whether it is a correct card, a proper card, okay, that is verification. But the password, we need to check with the existing password, same or not. So that is validation. So validate the password, not verify password, wrong. Okay, so you need to know when to use verify, when to use validate. Validate is checking on the correctness. Validation is checking on the correctness. Remember, verification is more on format, standard, rules, these are the things. Okay, clear? You need to know this very clearly. Okay? Okay, now look at this one. Okay, requirement model validation. Example of validation. Okay, one of the primary business objective for chemical tracking system is reduce chemical purchasing expenses by 25% in the first year. This is one of their business goal, business requirement. They want to reduce the chemical purchasing expenses 25% in the first year after implementing the system. Okay, use case. A use case that aligns with this business requirement requires a chemical. This use case includes a path that permits the user to request chemical container that already available in the chemical stock room. Okay, as shown in the next slide. Okay, here's the use case description. The requester specifies the desired chemical to request by entering its name, chemical ID or name, okay, and then by importing its structure from a chemical drawing tool. The system either offer the requester a container of the chemical from the chemical stock room, or let's the requester to order a new one from the vendor. Okay. So now you see, obtain material, safety data sheet. Okay. Request for a chemical. This is the important one. When requesting for the chemical, right? Okay. You see, when requesting for the chemical, this is also linked to here. Okay. And here search vendor catalog, manage inventory. Okay. So what do you understand now? Partial use case diagram for chemical tracking system. So how can you ensure that you validate this requirement? Validate this requirement. You want to reduce the expenses of purchasing chemical? Yeah. What can you do? What can you do? How to reduce the purchase of chemical? Can simply let someone to decide, okay, when your staff to decide whether buy or not, without checking whether the chemical already exists in the stock room. So first thing, try to check whether the chemical exists in the stock room or not. If exists in the stock room, sufficient, automatically cancel. Don't allow them to proceed with the purchase. Second, every purchase must go through the approval. Every purchase must go through the approval. So these are the two steps you can implement to make sure the chemical unnecessary purchase will be avoided, so that you can reduce your purchase by 25%. You understand or not? So this is one of your business requirement. So as a developer, okay, you need to check, is this fulfilled or not? This business requirement has been fulfilled or not? So you need to see whether is there any approval, okay, use case given, and is there, before you confirm this function, is there any approval for this function? Second, is there any validation? Can simply purchase, or is there any validation done? You really need to purchase this chemical or not? These are the things. So this is validation. This is not verification. Because business requirement is a source. You want your requirement to be aligned with the business requirement. So it is validation. Understand or not? That's important. Okay. Okay, model verification. Now verification. Model verification, any external entity in context diagram which is not relevant to the system. You have one external entity, but there's no data flow in or flow out. Got one entity, but not used by your system. Do you need to draw that? So unneeded information. So that is verification, knowledge. From your knowledge, you know whether this is how you draw the diagram or not. This entity needed or not. Okay? Any input or output data flow of the lower level DFT not found in the level 0 context diagram. Wrong. All the context diagram data flow in and flow out must be consistent with your data flow in your level 1 DFT. Cannot be extra, cannot be less. Must be exactly the same. Okay? Any relationship in PR diagram with inadequate multiplication. Yeah, I always find this mistake in my students' work. Class diagram or ERD diagram. Okay, 1 to 1, 1 to many, many to many. Sometimes you put wrongly. Okay? So any relationship in class diagram we can say, is this object communication message in sequence diagram declared in respective class in class diagram? Yeah, in your sequence diagram you have 3 or 4 classes, let's say. All these classes exist in your class diagram. Suddenly I see a new class in your sequence diagram, but there is no such class in your class diagram. No, wrong. Verification. All this checking are called verification, not validation. Verification. Any state diagram has multiple initial state. Verification. Okay? Okay, time for you to do now. Can you try this? I will call someone to explain. What are the intra-diagram check? What is inter-diagram check? Intra means within this diagram, what can be checked? Within this diagram, what can be checked? Inter-diagram means comparing more than one. So within 2 different diagrams, what are the things need to be checked? Within this 2 diagrams, what are the things can be checked? So can you try now? Also, taken from past year. Can you try? Can you have your grade? 1, 2, or 5 minutes?
不爽啊！这是不是在连4买4撞到？叫我找。早就开始了。因为我们今天那个
DFT got a lot of process, right? Then you have the data flow in, flow out. Then you have your data store. So what do you check? First, you can check if data store is there or not. You have identified the data store or not. Then you can check if there is any missing process or not. The flow, one by one process. Is there any missing process or not? Then you can check if the data flow in and flow out all done correctly or not. This is called intra. Follow the one diagram. What are the things you can check? You can also check whether the process shape is correct or not. The notation. You can check if the flow line got arrow. No, right? DFT must have arrow. Not like use case. Use case different. Use case association no arrow. Include exclude must have arrow. But for DFT, every single line must have arrow. So you can check if you have identified, drawn a correct notation or not. The model in a correct notation or not. Use case diagram. What can you check after drawing your use case in exam later, final exam? What do you check? See whether the number of use case you have identified same as the number of functions you have identified. In your scenario, got 10 functions. Check if you have all the 10 use case or not. 1. See whether the use case shape, correct notation or not. Got boundary line or not. Got title or not. Every use case got linked with the actor or other use case or not. Okay, got association for every use case or not. Okay, include, exclude have been identified or not. Okay, format. Okay, then the font, the label. Have you used the correct word to label or not? How to label? One verb, one noun. If can, try to keep to 2 words. Don't go more than 2 words. If really cannot, like missing details, then you can throw 3 words, still okay. But don't write like a long story. I remember when I was checking you, invigilating you for the midterm, one student draw one line. I don't want to mention. This is what I saw. I don't even remember the student face. Okay? I saw one page. The student has drawn use case, wrote a very long sentence until the end. then got no space to draw the line. No space to draw the line. So the student at the end had one line at the corner. Then the student was thinking how to draw the actor. Because the actor also haven't drawn. You know what? Use case, you shouldn't write a sentence. Use case, try to keep to 2 words. Don't go more than 2 or 3 words. The mistake is there. That's why you got no enough space to draw within 1 page. You understand or not? 2 or 3 words enough. You understand the function, I understand the function enough. No need to write long essay. Okay? Then make sure you draw the actors correctly. Okay, boundary line, all this. Okay, now comparing 2 diagram. Inter means within 2 diagram, between. Okay, so compare these 2. What can we check? Who can tell me? What is the similarity between these 2 diagrams? Can tell me. DFD and DRD, what is in common? There is one thing in common, so you need to check on that. What is in common? Do you show the process in your ERD? DFD, yes. Do you show the function or process in ERD? No. So what do you show in ERD? Entities. So all the entities you identify in DFD, no external entities, those entities must be consistent with EFD entities. You introduce something called participant, but in your ERD got no participant entity, wrong. Whatever entity found in ERD must be same as your system entity in DFD. You shouldn't have different unique entity in any diagram. They have to share the same entities. Understand? Okay. What about class diagram and sequence diagram? What is common? What is same in both diagram? What is common in both diagram? Anyone? Sequence diagram and class diagram. What are the same thing found in both diagrams? Okay, there is something very important which is common for both. What is that? Yeah, classes or objects. Classes actually, the classes. So the classes in your class diagram, later you will show in your sequence diagram to show how they interact with the user. When user perform a function, how the behavior of the classes change. These classes must come from the class diagram. You cannot create your own class in your sequence diagram. All the classes that you have identified for sequence diagram must be based on your class diagram. They are they actually from your system structure. So it is from your class diagram. You cannot have new class in your sequence diagram. Wrong. Understand or not? So that's how you ensure the consistency between 2 different diagrams. So easy for me to check your assignment later. I will always check this. When you draw the models, some functions can be extra, some can be less. I cannot say wrong, right, because it's your logic. As long as it's logical, common practice, I don't simply minus the mark. I look for consistency. I check whether you understand what you have done. So I check all your diagrams consistent or not. You understand or not? Okay, SRS, that's the most important thing. We check everything is consistent or not. What you mention in your elicitation, tally with what you do in your specification. Tally with what you have done in your validation. So we check like that. No. So that's how we check. Okay? Okay, continue. Few more slides, then you can go back. Okay, who can tell me what is the acceptance test? Anyone taking testing for this semester? Testing usually 3rd year paper. So you are not taking now, right? Testing. SQAT, Software Quality Assurance and Testing. One of the course every software engineering student has to take. So you are not taking this semester. Okay. So what is acceptance testing? Any idea? After you done your project, after gone through all different testing by the team, testing team, final testing, UAT, user acceptance testing, final testing. You will try to, if it's a hardware-based system, you will try to set up the hardware and the system is installed. You will invite your client, your customers. It can be done in your place, it can be done at the customer place. You can even deploy the system in their place. Invite at least 20 or 30 people, depends on the population. Invite them, ask them to conduct the testing. Final testing before you release the product. Close the contract. Okay? So they will conduct the testing. When they conduct the testing, you will give them, usually will be given a what to test. Then we'll be given a survey form. A survey form, see whether they're happy with the system or not. They're satisfied with the system or not. Like my teaching. The last class I give you an evaluation form to see whether you all understand what I teach or not. Like that. Your product, you want to know whether the customer's happy or not with the product. So you pass the form. Okay? And then ask them to really sit and test. They can test everything like stated in the checklist, and they will, at the end of the testing, they will comment. So that is UAT, user acceptance testing. So if they are not happy with the product, they will, at the end you have to calculate, do the statistic and see whether most of them agree with the product, happy with the product, satisfied with the product. Then the system will be launched. Otherwise, it will go for another change. Okay, next week topic. Okay, change requirement. You understand or not? So that is UAT. Okay, why I put UAT under this? Okay, you can see here, acceptance test. Okay, customer assess whether a system satisfies. Okay, predefined acceptance criteria. So this is what? This is requirement. So yeah, they have to see whether their requirement have been achieved in the final product. If not achieved, they reject. Okay, so the product satisfies its documented requirements or not. So that's why you see how the acceptance test linked to the requirement document. So whatever they have given during the requirement engineering, they will see whether your product, when you develop, achieved all the requirements they have stated last time. So if it doesn't, or let's say your product doesn't cover the requirement, doesn't satisfy the requirement, they usually reject the product. Okay, UAT. Okay, so now defining acceptance criteria. Okay, creators of acceptance tests should consider the most commonly performed and most important usage scenario. Okay, so normally they will go for the normal flows and they will also consider the exception. You cannot just test all the positive flow, common flow. What happens if I accidentally type wrongly? Okay, what happens if I accidentally enter the wrong data? What happens if I accidentally submit the button before filling up the form? So you have to go for the negative flow as well when you are preparing your acceptance test. Okay, so you cannot be just testing all the positive flow, later some of the negative flow or error cannot be detected. Okay, so you need to cover both. Okay, acceptance criteria could also encompass dimensions such as following. Okay, so let's go one by one. Specific high priority functionality. Usually, right, if you want to conduct acceptance test within 2 hours or 3 hours to test everything in the system, complete testing, So we go for this type. Okay, what we do, we cover only high priority functionality, or we ensure all the high priority functionalities are included in the test. Okay, essential non-functional criteria also, we make sure we have metrics to measure. That's why I say, you simply say the system should have no downtime. How they going to test later? So when you say something, they will see whether the quality have been fulfilled or not, achieved or not. Remaining open issues and defects. Yeah, any open issue defects. Specific legal compliance requirement. And finally supporting transition infrastructure and all the external requirement. So usually you will pay attention on high priority functionalities. If you got not enough time to test everything, pay more attention on high priority functions. Then non-functional, very important non-functional, see whether all measurable or not. Use the metrics to see. Remaining open issue, and as I say, compliance and external requirement as well. Okay, what is good about acceptance criteria? These are the acceptance criteria. Okay, so the value in writing acceptance test is it guides user to think about how the system will behave following implementation. Okay, this is like when you do the acceptance testing, it's kind of training for you. You will be exposed to the system. You know how the system will behave. You study the system during the testing itself. Okay, the problem with writing only acceptance test is that the requirements exist only in people's mind by not documenting or comparing alternative views. So you only test the requirement, but when you implement, it's not only that one. It can go in other flow. What happens if I type the wrong information? There is another negative flow, not only the positive flow. So that's why it's not possible for you to drawback. Okay? Any question? Any question in this chapter? There is only one more chapter, but I'm very sure today I wasted 20 minutes just for this. Okay, next class I will be here on time. I think I can cover the next chapter within 1 hour. So the next 1 hour, I'm going to do revision with past year. Then your Friday class, I will be still here. I won't cancel any class. Okay? So I'll be here to do some revision with you. So if you come, you will get some exposure how your final exam questions going to be. What are the topics usually will be tested in final exam? What kind of questions will be asked in final exam? I'll try to find some papers which similar to my current paper. So at least when you come, you get the exposure how the question look like. Okay? So next week I will start the revision. Okay? In Tuesday itself I will start the revision. Then I will share the past year papers in the classroom. But don't ask for marking scheme. We don't have the marking scheme. If we have also, we are not allowed to share with students. That's why I will try to discuss each and every question in the class. If you want the answer, you have to come for my class. Okay, don't ask for marking scheme. It is really not allowed in CAR to share the marking scheme. You understand? Okay? So that's all for today.